Hi, I'm Scott Klein, a technical evangelist with the DPE team. I'm here with Cihan, who's a program manager on the SQL Azure team. Cihan, why don't you introduce yourself and give us a little idea of what you do?
Sure. I'm a program manager in the SQL Azure team, and I focus on the programmability surface of SQL Azure, and especially on the scale-out programming model.
Because we want to talk about SQL Azure Federation, something that we're all passionate about, and we want to get the rest of the world passionate about it. So why don't we give us an idea of what that is?
What federations is really a way for the database to participate in the same model, borrowing the same technique for the database tier. Mm-hmm. And obviously it is a persistent data tier, it's not stateless, etc. So there's some of these differences, but in the database tier we can actually do that repartitioning with federations without any downtime. And that's the big upside to this, is that it really amplifies some of the principles we set for the Windows Azure platform, which are it should be elastic, it should be pay-as-you-go, it should be highly available, and it should manage all by itself. And scalability and managing scalability is one of those things that really is engraved into the principles of Windows Azure. And I think this, once you look at federations, it's not too hard to imagine that this actually takes it all the way to being able to kind of scale the database tier in some automated fashion. Federations is really a partitioning technique that's used very commonly out in the industry. It's kind of many of the popular websites that you go to, the social networking sites, auction sites, and things of that nature, are all using this technique to really decouple and decentralize the processing completely. So techniques like table partitioning are within a single database. They're not really about completely decentralizing. But federations is really about decentralizing processing to many nodes as possible. And it's about massive scalability. You can start small, obviously, but it's about massive scalability and being able to push your application to whatever the data tier requirements are and be able to harness hundreds of nodes if you need to. You can imagine with most of the Microsoft products that are switching from on-premise models to cloud models, they're building cloud services that are much like SQL Azure. In fact, SQL Azure itself is a multi-tenant service, and we use very much the same techniques in SQL Azure. So, but for all of these customers who are actually coming in, internal and external, when you want to stand up a cloud service, there's unpredictability about how many customers will actually come in and how large they will be, etc. So a static distribution of your data to, like, say, 50 databases or 20 databases just does not simply work. And some of the models of tenancy is not flexible enough for you to kind of take advantage of the full density of databases. Sometimes your tenants are really small, sometimes they're actually large. And so federations give those kind of ISVs, the software vendors, great flexibility in being able to kind of densely populate their tenants into databases when they're small. But as they grow up, they can actually kind of expand and spread them over to many nodes. The model is slightly different. So if you want to bring in an existing application, there's no easy way to kind of just rip out your existing SQL Server database, put it on federations, and simply just scale that out. There's work to do, and there's things to think about. And I can summarize that in kind of 3 steps. And one of the things that you need to kind of decide when you go to federations is obviously how to distribute that data. You need to tell the system, and federations allow you to express that, how you want to scale out your data. And that could be based on one dimension of your table or a different dimension of your table. And you need to annotate your schema and tell us what the federation key is within your application. That's step number 1. Step number 2 is some of your schema will actually, with federations, it's a decentralized setup. So the schema is distributed. You can imagine it to be, you're looking at that single database, you're taking out certain tables, a collection of tables maybe, and scaling them out using the federation key. But with that, you're actually pulling parts of your schema and putting that into a different database within the collection of databases that make up your data environment, data tier. So with that, the programming model of accessing the information, where each table lives and how you actually access them, is made extremely simple in SQL Azure, but you still have to issue additional commands to navigate, for example, to the right federation or to navigate to the correct federation key. So if this was a multi-tenant system, you basically have to express in T-SQL statements which customer you'd like to work with, and we can take you there. But those are all connection switches that you really need to kind of go do, and there's some of these additional commands you need to run. And lastly, the data is spread over to many of these federation members. So when it comes to working with this data, you're basically dealing with, in V1 especially, compartments of databases that hold parts of your data. So when you want to do aggregations or address all of your data, given that the scale targets are large, you may want to engage different programming models. So the federation model really allows you to parallelize processing extremely large set of data by engaging many, many nodes, but at the same time collecting all of that data back together. There's some additional work that you need to do. And some of the libraries provide great help. There are many samples that kind of give you great help. But these are some of the differences compared to a single database model that logically represents all of that data just as a single table. When I think about multi-tenancy, there are many models of implementing that in a single database, where you could choose to use schemas, or you could choose to use a single table and then use a tenant ID like property that kind of splits up the table.
Yeah, customer ID, which defines customers, and that right.
And I think the model that's more naturally engraved into multi-tenancy to really give you kind of all the optimizations is more based on a single set of objects, but a logical tenant ID that kind of divides up those tenants into slices of rows. So a collection of rows belonging to a specific table. So that tenancy model is going to easily translate into SQL Azure Federation. The other kinds of models, we actually, there may be other ways that you could actually set this up. Obviously, it's a programmability surface, but those kind of setups are not easy to translate into SQL Azure Federations. It's not to say you can't do it. It's just that the nature of multi-tenancy and the benefits that you actually get, that accordion effect. The way to get that is really to kind of use the tenant property and tenant column inside. I think there's a couple of interesting things to consider. One of them is people who are actually moving their existing databases over, that are looking for an easy way to kick that into the cloud. And I'd say federations can help, but there is work to do. So one of the things that is important to consider is that the decisions around how you're going to spread your data, the federation key, are key parts of your design decisions. And for an existing application who's kind of lived for a decade or so and has actually kind of evolved over time, sometimes it is not set up with the same kind of mentality to bring into the cloud and to bring into the federation environment. Federations is, again, a decentralized processing capability. It scales your data out to many, many different nodes. And while it's doing that, it employs some of the more modern techniques as well. It brings in things like eventual consistency and distribution of a single schema into many databases, right? Those are concepts that are not necessarily easily represented inside a single database. And if you want to take advantage of some of this decentralization and some of this scale target and be able to really hit 100 nodes and not really kind of hit a hotspot, you really need to kind of think about those things a lot. And I think that is going to be kind of one of the key factors for a lot of people who are willing to move is really to go back and take a look at your application and understand what type of key things to kind of change. In some ways, if you're looking at whether to go with a single database model or not, I think the question is really this: are you safe to assume that you will never hit the limits of a single node and a single database? And to be able to make that assumption, I think you really need to have a fairly small workload to work with. Most of the time, I think people, I don't know if a lot of people know this, but we made a hardware choice based on economics in the cloud. And that hardware choice is very much about utilizing machines that are price-performance optimized. Not the best hardware in the world, but price-performance optimized. And that's how we can actually give you the great economics. And if you start thinking about what a single node and a single database can do, that really, with all the added services like high availability and other things, that node is busy maintaining a whole bunch of high-level services like high availability for other databases that are living in other parts of our cluster. So 2/3 of a node, if you imagine what SQL Azure does, for example, with 3 copies of data, well, guess what? 2/3 of the node is actually full with those additional copies that we have to maintain. So it's that 1/3. And when you think about the capacity this way, there are some applications that you can definitely safely say, well, this is going to be a single application. But for many of the applications who need any type of reasonable transaction processing, I think you want to take a look at federations,
yep.
and you want to take a look at that.